Hi everyone, this is Mrs. Torigno, and this is the second half of the Chapter 7 Test Review Part 1, starting with question 8, and we'll go down through question 14 on this video. Okay, question number 8 wants us to take negative 3x and raise it to the power of negative 2. Just like I said previously, this negative on this exponent we are not going to worry about yet. We'll worry about that at the very end. Now that negative is totally different from this negative. They mean two totally different things. A negative exponent means that your answer is going to flip over at the end. This is just a negative number, and we're going to treat it like a negative number all the way throughout our problem. So for now, I'm just going to pretend that's a regular 2, just a regular square. So this is asking me to do negative 3 squared. Remember, negative 3 squared is like negative 3 times negative 3, which is positive 9. And then, again, ignoring that negative there, we also want to square this x, so that's going to become x squared. Now let's think about that negative exponent. A negative exponent always turns your answer into its reciprocal. So this right now, as it's written, is really 9x squared over 1. We are going to flip that, and we are going to make it 1 over 9x squared. It's really the same idea we used back here in questions 5 and 6, except our answer wasn't originally written as a fraction. That's okay. Remember, you can turn anything into a fraction by just putting it over 1. Okay, question 9 is where these problems get to be a little bit different than what you've seen already, because this one has a rational exponent, which, as you remember, is a fraction for an exponent. So the first thing I'm going to do is take this fraction and split it up. I'm going to write this as 64 to the 1/3 raised to the power of 2, because these are two different processes that I'm going to follow. 64 to the 1/3 means I somehow need to break 64 into 3 equal pieces. To do that, I will need a factor tree. So I know 64 is 8 times 8. This is 2 times 4, 2 times 4, and 2 times 2, and 2 times 2. So at the very bottom of my factor tree, I end up with 1, 2, 3, 4, 5, 6 2's. Now this said I needed to break it into 3 equal pieces, and right now I've got it broken into 6. This is where that box method comes in handy. I need 3 equal pieces, so here's my 3 boxes. And I have 6 2's that have to fit into those boxes. So ask yourself, how would I split up 6 2's into 3 boxes equally? Well, hopefully you'll come up with needing 2 2's in each box to get to your 6, and that means each box is actually equal to 4. And this is just to double check yourself. 4 times 4 times 4 does equal 64, which is what we started with. So that means when I broke 64 into 3 equal pieces, the 3 pieces were each of 4. So now I'm going to take one of those pieces, the 4, and put that in here and square. So this will become 4 to the power of 2, which is 16. So my final answer for this problem is 16. I apologize, I probably shouldn't have circled that 4. That made you think that that could be the final answer. But your final answer here would be 16. So now knowing that, let's take a look at question number 10. I'm going to have to move this over here a little. Just like I did before, I'm going to start by rewriting that exponent. So I'm going to write this as 16 to the 1/4, and then that to the power of 3. And to break 16 into 4 equal factors, I'm going to make a factor tree. Running in my own tripod there. And this one actually is a little bit more straightforward because I need it broken into 4 pieces, and that's what happens with my factor tree, is it breaks into 4 equal pieces. So this 2 is what I need. Now I'm going to take that 2 and raise it to the power of 3. And remember, 2 to the power of 3 is not 6. That means 2 times 2 times 2, which is 8. And that would be my final answer for this one. So remember that the bottom of the fraction and the top of the fraction are telling you two different things. The bottom of the fraction tells you how many pieces you need to break it into, And then the top number tells you what power you need to raise that piece to. Okay, so knowing that, let's take a look at number 11. Number 11 has a negative fraction, so that's mixing two very confusing topics there. Again, let's ignore that negative. If that were just 9 to the 1/2, that would mean I would need to take that 9 and break it into two equal pieces. If you were to make a factor tree for 9, it would be very short. It would just be 9 is equal to 3 times 3. So 9 to the power of 1/2 is just 3. Now, the fact that it's negative, oh, by the way, I can just leave it as a 3. I don't have to do this step where I raise it to a power because my top number is just a 1. So 3 to the power of 1 is just 3. But because this is negative, that means I need to take my final answer of 3 and flip it to its reciprocal. The reciprocal of 3 is 1/3. So that would be my final answer for that one. Okay. Number 12 is another negative fraction, except this one has a number on top other than 1, so that's going to require one extra step. Let's start by splitting up this exponent again. I know this is a step that a lot of people like to skip, but it really clarifies your process for you. It really tells you what to do when. So this time, I started with a 1/3 because my denominator was a 3. Then I put a 2 on the outside of that because my numerator was a 2. And then finally I put a -1 to show that that was a negative exponent. And I'm just going to follow this in order. So I'm going to break it into 3 pieces. I'm going to take that piece and square it, and then this -1 means I'm going to flip that answer over into the reciprocal. So let's start with my 3 pieces. If I make a factor tree for 8, I break into 3 equal pieces, and each piece is equal to 2. So now I'm going to take that 2 and raise it to the power of 2. And I'm just going to leave this -1 on the outside to remind myself to flip that answer over in a minute. 2 squared is equal to 4, and then of course that still to the -1, which means I need to flip that 4 over. That 4 right now is like 4 over 1, so when I flip it over it will become 1 over 4. And that would be my final answer for that one, 1/4. So 3 totally different things going on here. Just make sure that you pay attention to each one individually. And I get a lot of questions about, do I need to make a factor tree for this? Do I not need to make a factor tree? Anytime your exponent is a fraction, you're going to need to use a factor tree. Okay? So I would just watch out for those. Anywhere you see a fraction as an exponent, start with a factor tree, and that'll probably get you set for the next step. Okay, let's look at question 13 and 14. 13 is a division problem. And when you're dividing with powers, you should subtract the exponents. So that means that what I really want to do here is -1/5 minus 3/5. Now, when you're subtracting with fractions, you do need a common denominator. But luckily, this is already set up with a common denominator for you, so you don't really have to do much work there. Let's just do -1 minus 3, and we find that that's -4. And of course that denominator stays the same, so that's -4/5. For my answer then, I'm going to move it over here, I would have m to the -4/5. Now hopefully you're seeing a problem with that, because a negative exponent is not considered to be simplified. And if you look back up in your directions, it says that all of your answers should only have positive exponents. So let's take this and rearrange it just a little bit to make it so that it has a positive exponent. Let's think of this as m to the -4/5 over 1. That negative exponent is going to flip this to the reciprocal. So it will become 1 over m. And then remember that now that we've flipped it, that can be a positive 4/5. That negative has served its purpose. Okay, made the m move to the bottom. And that's it for that one. Number 14 is very similar. Again, it's a division problem, so I'm subtracting. I'm doing 2/3 minus 8/3. Well, 2 minus 8 I know is -6/3. And now this one can actually be reduced. It reduces pretty easily. -6 over 3 becomes -2. I skipped that step in the last one because negative 4 over 5 does not reduce. So really my answer here is d to the negative 2. But just like we did before, we're not happy with that negative exponent floating around there. So I want to move that to the bottom of a fraction, and I'll make it 1 over d squared. And that's my final answer for that one. Okay, that's it for the front side of your No Calculator test review. That's test review part 1. The next video will cover the back side with the equation solving.